Scientists have been studying gases for several hundred years, so there's a wealth of information available to help us understand and predict the properties and the behavior of gases. One way that scientists have developed to help the novice learner learn about the properties of gases is to use something called a gas simulator and use animations to try to visualize the properties of gases. We're going to take a look at a gas simulator that we're going to use in this unit to help us understand the properties of gases. First of all, in the gas simulator that we're going to be using, we're going to treat the gas as a particle. And what we mean by that is normally when you think of matter, matter can exist as atoms, molecules, or formula units. And when we think of an atom, we think of just, a lot of times a model will be just a sphere. For example, helium. You might model a helium atom with a single sphere to model the atom. For a molecule, molecules are covalently linked atoms. And so, for example, this is a classic way to model the molecule water, where the open sphere would be oxygen and the two closed spheres would be hydrogen. And a formula unit, smallest whole number ratio of ions, I should say, in some sort of ionic compound. For example, for sodium chloride, we might have a model of with a circle with a plus in the middle for the sodium and a minus in the middle for the chloride, and we know that they have a very strong electrostatic attraction. So we have different ways of modeling different pure substances. But when we're using the gas simulator, and when we're first learning about these gas laws, we're going to be modeling these individual atoms, molecules, and formulas as particles. So whereas the model for the atom may look like this, the particle, we're just going to assume doesn't matter which element it is, all of the atoms are just a single sphere. For the water molecule, rather than the three individual atoms, we just model the water molecule as a sphere. And for the formula unit or even individual ions, it doesn't matter. We still treat them as an individual sphere. So in the particle model, all of the different gases, regardless if it's an atom, a molecule, an ion, or a formula unit, are all going to be viewed the same as an individual sphere. So let's take a look at the simulator that we're going to be using in this class. There's a lot going on in this particular picture of this simulator. Let me make it a little smaller here if I can. Make it just a little smaller. There we go. In this simulator, the red spheres inside this cylinder are our gas particles. Okay, so we're going to model our gas particles. So this particle could be an atom, a molecule, or a formula unit. Doesn't matter. They all behave the same. In this particular model, these red spheres are all just a particle. Okay, so that's how we're going to model our gases, as particles. Individual, doesn't matter if it's an atom, a molecule, or what. Okay, the other thing that's very important here is that the particles are very, very small. Okay, the size of these particles are on the order of nanometers, which is 10 to the minus 9 meters, or even angstroms, 10 to the minus 10 meters. And so when we're talking about these particles, we're talking about the radius being on the order of nanometers or angstroms. So again, if you look at this simulator, the view of the simulator, if this particular picture here, the volume is very, very large, 709 in this case liters. Obviously we're way out of proportion with the size of our particles. So we have to use our imagination. If we were to try to simulate the particles as the actual size, of course you would never be able to see them. That's why we can't see gases. So we've blown them up quite a bit for the purpose of starting to develop a conceptual picture of a gas, but we need to remember that these particles in reality are very, very tiny in relationship to the container that they're in. Okay. Let's take one more look at the simulator so that when you start using it, you'll be ready. This is a pump, and the purpose of the pump is to add more gas to the container. So we can add gas by tapping on the handle to the pump. Okay. This is a release valve, and so we can release gas by tapping on the yellow valve here. Okay. We have two different gases. We have a yellow gas and a red gas, gas A and gas B. We are monitoring the pressure here the temperature here, and the volume here. These knobs, when you tap on them, will cool the container down or heat the container up. So you will be manipulating this simulator to answer various questions and try to relate properties. Okay, one more thing to show you is the actual simulator in operation. And in this case, you can see if you tap the handle, more gas will go in. Okay. If you tap or highlight the other gas, we can add the other gas. And since they're both highlighted, both gases are going in. Okay. And we can turn one off and just add one. And you can see that the pressure is changing. The volume we've locked constant. The temperature is constant. You can add heat or cool it. We'll look at these other boxes later. Collisions per second, root mean square velocity, and average kinetic energy are what they're representing. So these are the some of the microscopic behaviors of the particles that we're going to relate to the macroscopic measurements of the particles.